continuing on. So we talked about absolute value. Now let's talk about this one. You need to be very comfortable with the use of negatives. So when they say properties of -1, 0, and 1, properties of 0, just basically a couple of things. Either if we add or subtract 0 to anything, it just stays the same. Or if we multiply anything by 0, we end up with 0. Pretty straightforward. Okay? Now, one thing you want to watch out for, and this pops up a lot, because they want to trap you on this, division by 0 is undefined. So where this might pop in on the exam would be, say you had something like this. I'd say, let's say we have 12 over x plus 3. Let's just say. And perhaps the question might be, well, what can x not be? You know, your red flag should kick in. If we've got division, if we've got a denominator anywhere, the only thing we have to make sure of is that the denominator is never, in fact, I'm going to put it, denom is never 0. Okay? So what this would mean is that any number that we picked in for x that if we added to 3 that ended up making this denominator 0, we can't do that. So what you would do is you just basically, this is the sort of the formula here, is I would set something like this. I'd say x plus 3, take that denominator, and I'd say let's set it equal to 0 and solve for x. And hopefully this is relatively basic algebra here, but we could subtract 3 from both sides. That cancels that out, and that gets us to x is equal to -3. Since that's the value that's going to make this denominator 0, we know x cannot be equal to -3. Right? If the big takeaway here is that anything that makes a denominator 0, nope, not allowed. Okay? So just make sure that you do that. And then finally, in this, whoops, what did I just do? Sorry, that's not my, there we go. And then the idea too is if we multiply by 1 and -1, very, very basically here, all that's going to do is either, if you multiply anything by 1, it stays the same. But if you multiply something by -1, it's going to shift its sign. It's going to stay the same number, but the sign is going to be different. So, again, sort of duh, if I've got -3 and I multiply that by -1, the negatives would cancel and I'd end up with +3. Just make sure that you're comfortable with that. Okay? Then, the next thing that we want to talk about is reciprocals. The reciprocal of a number, this is a vocab thing. If you have something that says reciprocal, all that means is flip number upside down. That's it. Upside down. There we go. So, for example, that the reciprocals could occur, do two different little lines here. We could either have a whole number, like 3, 6, 9, 27, -5, whatever, or it could be a fraction, 1/5, 3/4, 2/9, whatever. But here, let's just say we have a whole number, and we're asked to find the reciprocal. Well, let's just take the number 3. Remember, every time that you have a whole number, you can describe that as, you can always slap a 1 underneath it, right? This 3 over 1 just means the same thing as 3. Think about that. Possibility of being big. But, okay. But this helps us when we're trying to find a reciprocal with this, because reciprocal just means flip this thing upside down, so the reciprocal, put little r for reciprocal, is just going to be 1 over 3, right? We just take the 1, we dump it up there, we take the 3, we dump it up here, we're done. Okay? Now, same thing. If we have a fraction, say, we had 3/17 was our fraction, and I asked you what the reciprocal was. Well, that's just going to be flip it around, 17 over 3. That's it. That's all you're going to do with that. The key idea with reciprocals is that if you multiply a number by its upside down version of itself, you always end up with 1. You can kind of see that, right? If I did 3 over 17 times 17 over 3, we end up with, 17s cancel out, 3s cancel out, we just end up with 1. That's it. embeddeds. Okay, again, 5-minute mark. We'll pause and we'll keep going.